Now we have generated or regenerated our water, and we can close the cycle. So use the regenerated water instead of the fresh water here. But let's first have a look at the mass balance. So I select both streams again by using the Control button, edit streams, and if you look at this mass balance of water, we see here we use 109,348 kilogram of water, but the amount of regenerated water is slightly less. It's only 109,336 kilogram per hour. So our process is losing water. What does this mean if we just close the recycle, so connect the stream 7 with the stream 1? This means that our process will lose water, and with each recycle iteration, the amount of water will become less. So we will need some makeup water. On the other hand, we're getting some components accumulated. So here we have air dissolved in the regenerated water stream, but the air is not in our freshwater stream. So some components will accumulate and others will vanish like the water. So what each process with the recycle needs are a makeup stream and a purge stream. With the makeup stream, we can fill in water, which we are losing during the process, and with the purge stream, we can remove components that otherwise would get accumulated. So we need some more units to modify our process. Commonly in a process, I would first purge and then use the makeup, but for numerical reasons, it's easier to do it here the other way around. So I will add some fresh water. Therefore, I select the mixer where we'll put in our makeup water. And then in the next step, I will use the divider in order to remove the purge stream. And then I can close the recycle and connect this to stream 1. So here we will have our makeup water. For better numbering this, so stream 7 goes into the mixer. Here's our makeup water. Let's give it the temperature, ambient temperature, ambient pressure, and let's fill in 1 cubic meter of water per hour. And we connect the mixer with the divider. Here we have our purge stream. And there's our purge. We will calculate it. And now we connect our scrubber column with the divider. To rename it, so go from here. Stream 1, water. And this stream becomes red now because it is a recycled stream, which is calculated iteratively. And we can specify it which size it should have, which flow rate. So here I don't want to use the flow ratio, but I would like to use the flow units defined below. So standard cubic meters liquid per hour. And stream 1, we've seen like 110 cubic meters per hour works fine for our process. So this here in this unit, we specify our degree of freedom, which is the water flow rate. Okay, let's calculate the units step by step. So here we have our regenerated water. Now we run this, fill up our stream with the makeup water. So let's see that we have sufficient water in this case. And we have 110.34 cubic meters per hour. We run the divider, and here we see at this point now we have 110 cubic meters per hour as regenerated water. And the surplus amount of water with our accumulated components like air, methane, carbon dioxide, which is still inside, is removed at this point. And now we have a closed recycle, which must be solved iteratively, because you remember when we started, we had no air, no carbon dioxide at all in this water stream. Also, the temperature is increasing. We see here, we fixed now the mass balance, but we have a problem with the energy balance because the temperature is increasing. We start with 5 degrees Celsius and now we have 5.2 degrees Celsius. So we need a heat exchanger in order to cool down to 5 degrees Celsius again. Let's put this here in front of the scrubber column. And I will connect it this way. Reroute stream. Stream 1. And here we close the recycle from the divider. This is our stream 11, and this heat exchanger, we want to use it in order to cool down the water to a temperature of 5 degrees Celsius. Now we have a process with a closed recycle. And we can run our entire flow sheet. And we see after 4 iterations, the simulation has converged. And we have now a closed loop, closed cycle process where we remove our carbon dioxide here and we produce a clean biogas with 99% of biomethane.